Hello everyone, it's June the 4th. Man, I think I'm getting pulled more and more towards also Haskell. I wonder if it's even, I don't think it's, I have Elixir, I have Scala. It doesn't have Haskell here, but man, I'm seriously thinking about, getting really deep into this. It's very interesting. Because I just learned something. So yesterday, I learned about monad. I kind of have an understanding of what monad is. And today I looked into lambda calculus. It's very interesting. Very interesting way of defining computation. Yeah. Well, anyway, let's get today's going. Find common characters. A string of array of words return an array of all characters that show up in all strings within the words. So L shows up, E shows up. Huh? All characters that showed up in all strings within the words, including duplicates. Oh, because LL shows up in all of them. Okay, so we need a counter for every single one, right? And oof. So you have a counter, then you go through every single one. Nope. I'll have one counter. I go through the first one, so I record and go through the second one, and you will record the minimum. Right? You will record the minimum. Yeah. Okay, so that's that. Ooh, you look great. Alright, so basically what we need is a counter 26, right? For string, word, or for words. Okay, what do we do for each one? For char C of word dot to char array, and if it's 0, right? If we say counter C minus A is equal to 0, then counter C minus A. Alright, I'm probably do it this way. Int I equal to C minus A. So we say this equal to 1. Ooh. Nope. So we need a counter. Okay, we need a counter and we need another counter. And once we get another counter, then we'll compare to the first counter. Damn. Okay, so that's not right. So we need a temp. Okay. And this one shall be easy to do. So just say temp C minus A plus plus, okay? And once we're done, then we're gonna go through every single one for int I go to 0, I smaller than 26, I plus plus, right? Then we say if counter I is equal to 0, then we say counter I is equal to hold on, what you trying to do? I want to see for each word, I put those in, right? And for the next word, I want to see how much overlap there is, right? How much overlap there is. And if it's a 0, that means it should be no overlap. Which seems to me that the first word has to set the tone, right? The first word has to set the tone, and the second one, the first word set the tone, and the second one. But if it's a 0, I apply it. But it depends on if the first one is a 0. No, the first word needs to set the tone, and everybody comes up, and then we just get a minimum. Right, we get a minimum. If it's a 0, then it's just gonna be a 0. Yeah, okay, so we need to say for char C of words 0 down to char A, and we say counter C minus A plus plus. So that's set the tone. And for here, for int I equal to 1, I smaller than words dot length I plus plus, and the string, actually it's fine. We have a temp, and here it's gonna be words I, then temp. Right now we go through this, and we don't do this. Okay, we simply say counter I shall equal to math.minimum counter I and temp I. Right. So once we're done, we will say list string rest new array list. Okay. Then for int I 0 I smaller than 26 I plus plus. Right. And then for int j equal to 0 j smaller than counter I j plus plus, and we say rest dot add string. How do I turn? Actually, I don't know. Java. Turn char into string. String the value of. String the value of a plus j, not j, I, and we'll return res. All right, duplicated I. I already have an I, so this is cannot be I. Let's do I. Okay, so I. So counter I. Right, and then okay. Let's try this. Oh, I have to char this thing, right? Damn. Yeah, I think you have to char this thing. Yeah, I have to char this thing. (1002). Count the frequency of letters in the first word. Then compare the frequencies of all the other words and keep track of the minimum frequencies. Call it ON. Well, technically it's ON squared. Because for each word we have to go through this. So yeah, actually I think it's ON squared. ON times M. Okay, let's try this. I guess it's fine. Frequency intersection, that's what they call it. Yep. How is this correct? You should get a minimum. Create a counter for each word, then does set intersection of all consecutive pairs of word counters. Consecutive pair of word counters. Common characters. Oh, I guess this is, well, get the minimum. Yeah. And you have dot elements. Yeah. All right, anyway, so that's that. Okay, we get back to this one. So we read through the hints yesterday, so I kind of understand. Basically, we will break this K down. Let's have this type of method called binary lifting. So we break K down into binary version, right? So basically for this 4, we can actually do an example, right? We do an example and we start from, where do we start? Oh, choose a starting, doesn't matter where we start. So we have 2, 0, 1, right? And then K is equal to 4, which is 1, 0, 0, right? Okay, but what we want to do is we have two things. One's called last receiver. Okay, last receiver we have an I and J. Okay, so I is the starting position, right? Starting position. That's starting position. yeah, is a starting position, and J is, what is J? J is the position in here. Okay, so J is the jth position in the binary of K. Okay, so let's just call it LR, right? Last receiver. So if we go last receiver, if we start from 0, right? And we have here is just gonna be 0, last receiver 1, last receiver 2. Right, so we start from 0, this position, and we're gonna go to this, go to the 0 position, like if that's a 1, right? So that's go one time, right? That's one time, right? This is one pass, right? We call it pass. And this is gonna be here, so that's 2 passes, right? And this is 4 passes. So here, if we start from 0, right, and then we do 1 pass, and 0 is starting from here, and we do 1 pass is passed to 2. So now the last receiver is gonna be 2, right? And if we do 2 passes, actually there is a better way. I think we shall probably do it this way, right? So we're starting from 0, and I'll have 0, 1, 2. Right, something like this. Can we even do it that way? 10 to the 5th. Anyway, so we started from 0, and we have 0's position, so 1 pass, so we pass to 2. If we're starting from here, 1 pass, we pass to 0. We start from here, 1 pass, we pass to 1, right? And there is a thing is, if you starting from something and you have, if you want to do LR, you know, we're starting from I and with J, right? But you don't know what this is, and this is equivalent to you start from I J minus 1, right? So you start from this. I will wash the dishes. Don't worry about it. You start from the J minus 1, and then you will go J minus 1, right? That's the key. So this is the key, which means in this case, if I want to do LR, we start from 0 and end at 1, which is equivalent to LR, we start with 0 and end with 0. We start from here and we do 0. So this we already know. This is 2, so this should be LR 2, 0. And 2, 0 we also know. So this is actually equal to 1, which means we start from 0, we go 2 steps, right? First pass we go to 2, second pass we go to 1, right? So the same thing here, if we start from 1, and we basically do, because we want to do 1, 1, so we need a 1, 0, right? A 1, 0, and so it's basically 0, 0, so this will be 2. And this is the same. We want to do 2, 1, so we first need a 2, 0, right? We need a 2, 0, so that's a 1, and do a 1, 0, so it will be here, right? So now, the same thing, if we do LR 0, 2, that shall equal to LR 0, 1, right? And then 1. So we want to do 0, 2, we find 0, 1 first, and then we check here, and then we do, so this one will be 2. Really? So you say 4 steps, starting from here, 4 steps. 1, 2, 3, 4. Should be 1. Huh? Alright, let's make sure everybody else is right. So we start from 1, okay? 1 step, go to 2. No, 1 step, go to 0. Yeah. 2 step, go to 2. That's correct. We start from 2. 1 step, go to 1. 2 step, go to 0. That's correct. If we start from 0, 1 step, go to 2. 2 step, go to 1. Right. 3 step, we'll go to 0. 4 step, go to 2. Yeah, that's right. Go to 2. It is go to 2. It is go to 2. Alright, we start from here. 1, 2, 3, and 4. I don't know how I calculated earlier, but that's correct. Oh, I thought it's gonna be 1. No, I want to record the position. So here, we want to calculate 1, 2. So we go to 1, 1. That's a 2. And find a 2, 1. Right? So that should be a 0. Here, we want to find 2, 2. So we go to 2, 1. So that's a 0. And I go to, so that's a 1. So, okay. So this is the LR. So the last receiver. So that's 1. And another thing that we need to consider is called a sum. Right? It's called a sum. So we're going to try to do the sum. So the sum will be exactly the same. Okay? So it will be a, in this case, will be a 3 by 3. Right? It'll be a 3 by 3. So this is a sum. So 0, 1, 2, and then 0, 1, 2. So we say sum ij is this still the starting position, right? And this is the jth position in the binary representation of k. Okay. And the interesting part is Sij, right? If we want to find Sij shall equal to S, so that's with j number of steps, right? So we say Sij minus 1, right? So we go basically half the steps, and that's actually not right. We shall, this is not S, because we need to know the final position. So with the last receiver of this, right, that should be Sij minus 1 plus, right, S this and j minus 1. So we find the last position about halfway through, and from there we go that many. So that's the kind of relationship. If we see the sum, right, yes, plus last receiver, yes. So that's that. And we will do exactly the same thing. So we start from 0, right, and we do 1 step. So we'll end at 2, and we will add all of the paths. So that's actually 2, right? And then we start from 1, and then we end at 0. Then 0 is actually 2. So 1 plus 2, this is actually 3, right? And we start from 2, and we end for here. So we start with 2, and then we end at this position. So that's also 2. So this is what we start with, right? Now we're going to find S0, 1. Okay, so that shall equal to S0, 0 plus S LR 0, 0. So LR 0, 0 is essentially 2. So start from 2 and then we do 0. So this will be 2 plus 2. This is actually 4. Right? So basically we start from here, we do 2 steps, right? So first step is 2. Second step will be 3. Right? Third step will come here. So we end up at 1. Should be 3. Right? It should be 3. I don't know why it's giving me 4. Hold on. So 1 from 2. So this one is wrong. Because we start from here. So it's a 2. Right? And 2 plus this will be 3. And then we go here. Yeah, so it's not, it's actually, this one shall be, this actually, that's actually 3, right? This is actually 3. Because we start from, do we compute the starting from position? I don't think so. I don't think so. Because the starting position we will record. Hold on, and this is interesting. The starting position we need to, because the starting position we do not include. Otherwise we're double counting. So we don't count the starting position, and some not counting the starting position. So all we're counting is just the end position. So in this case, so that's 2 is correct, but we start from 1. Okay, and that's actually not right. Oh man, this is a lot of error here. Hold on, let me redo this. So we start from 0. I don't count 0 and then go to here. So I have to do 2. We start from 1, but I don't count 1 and ending at here. So this is actually 0, right? And we start at 2 and end at here. So I count only 1, right? Again, we do this without counting the starting position. So at the end, when we do this, we have to add the starting position. So now we say we want to start from 0 and do 2 steps, right? So it will be this 0, 0 plus 2, 0. So this will be 3, right? So we start from 0. First step, that's 2. Second step, that's 1, right? And this one is 1, 1, right? So we need 1, 0 plus LR 1, 0. So LR 1, 0 is a 0. So we need to do a 0, 0, right? So that's going to be a 1, 0. It's a 0 plus 0, 0. So that's a 2, which means we start from here. First step is nothing. Second step is here. So that's a 2. Okay. So now we need a 2, 1, right? So a 2, 1. So we need a 2, 0 and LR 2, 0. So that's a 1, 0. So it'd be 2, 0 plus 1, 0. So 2, 0 plus 1, 0. So that's a 1. So we start from here. First step, we get a 0. Second step, we'll go to here. So yeah, that's correct. Okay, so now let's keep going. We have one more to go. We need to find S02. And to do S02, we need first a 0, 1. And then plus S, we need to do LR 0, 1 and 1. Okay. So LR 0, 1. LR 0, 1 is a 1. So we need a 0, 1 and 1, 1. So 0, 1. And a 1, 1. So this is a 5. Okay. So if we do a 1, 2, so it's a 1, this is a 1. So LR11 is a 2. So it's a 2, 1 plus 1, 1. So that's a 3. And if we want to do 2, okay, so LR2, 1, that's a 0. So we do the 0, 1. So that's a 3 plus 1, that's a 4. Okay. Okay, so now we have the sum, we have this. Now we can go to k, right? And we want to find a k, basically, what we need is depending on what this is, right? So in this case, we have nothing, nothing. So this is basically the first one we need. So we can say that's directly an S of starting, 0, ending at 0 and 2. Okay, so basically it's gonna be 0 plus this, 1 plus starting from 1, ending at this, and a 2 plus starting at 2 and ending at this. So basically we need to find the maximum of these three. And if we have something else in between, then we'll go there first and readjust its end position, then we'll go here. Okay, is that correct? Because we'll do that number of steps first, then we'll do, like we do one step, then we do 2 steps. So we do a 1 step, right? And then we do 2 steps. I mean, it doesn't really matter. I think I can go left or right. I can go this much, and then we see how many. Yeah, it doesn't really matter if we go left to right or right to left. I think it does not matter. But in this case, we get the last one, right? Yeah, there's way to make. I can already see this can be made into one array, but this we do need everything. This we only need 1. No, we also need we need everything. So this is equal to S02. So this is 5. This is 1, 2. This is 4, and this is 6. Right, 4 plus 2 is 6. So the answer is 6. Yep, that's how it is going. That's how it is doing. I wonder if the memory can handle, because I need 2. Right, I need 2 giant tables. One for the last receiver and the other for S. And I haven't tested the other idea yet, but well, what tested? All right, so I'll keep this. So tomorrow we probably can implement it. Anyway, that'll be it. I'll see you guys tomorrow. Adios.